Hi everyone, I hope you guys are well. So we will be starting off with some past paper questions. This is winter 2142, I think, if I'm remembering it correctly. So this is winter 21 paper 42. Question number 3. Okay. Now, these kind of questions have been, you will see these kind of questions more often in the recent paper where you won't be using the data booklet and you will be using this table. But many students have this problem that they don't know what to equation to pick, right? So I'm going to try doing these kind of questions in order to help you out to understand that what equation to pick and what equations to exclude out of it. Now you need to know a few things. You know how to calculate the E cell, which reaction goes forward, which reactions goes backward as well. So using that, so let's, I think it is winter 22, not 21, my bad. Okay. All right, so let's look at the equations which are given to us. So we have electrode reactions and the standard electrode potential are measured under standard conditions. Describe the standard conditions used in SN4 plus and SN2 plus half cells. So we are talking about the standard conditions. You know what the standard conditions are. So standard conditions are when we have temperature of 298 Kelvin. Pressure we don't need, it's a gas, but if you want to write pressure of 1 atm, and you know square brackets are used for the concentration. So concentration of SN4 plus is going to be 1 mole per dm cube, and the concentration of SN2 plus needs to be in 1 mole per dm cube as well. Okay, so this is going to be for 1 mark. They're asking the standard conditions used in the 10 plus 4 plus 2 half cells. Okay, let's look at the next part. Complete the diagram below to show the E naught, SN4 plus and SN2 plus can be measured experimentally. Your diagram should be fully labeled to identify all apparatus and substances. Now you will find these kind of diagrams a lot in the papers, right? So we have half of the cell which is given to us. Yeah, okay. Now let's complete the diagram in the best possible way we know how to do it. So firstly, because we are using SN4 plus and SN2 plus, so we need to use electrode which is going to be not of 10, but we will be using platinum electrodes, and we have platinum electrode here as well. And because we're measuring the potential, so we will have one half cell is going to be for hydrogen and the other half cell is going to be for tin. And this, I think, is 3 mark. This is a 3 mark diagram. Sometimes the diagram is coming for 4 mark as well. So we are going to have 1 mole per dm cube of HCl or H plus ions aqueous, and because we have to introduce hydrogen gas, so we need something of that, and we are introducing H2 gas which is at 1 atm pressure. It's going to happen at 298 Kelvin as well. The electrodes need to be labeled as well. Voltmeter, because we need to know the voltage, so this is going to be my voltmeter. This is going to be 1 mole per dm cube of SN4 plus, and because we're going to have both the ions in the solution, and we need 1 mole per dm cube of SN2 plus as well. Okay, and we need a salt bridge, so I'm going to use a highlighter to draw the salt bridge here, and the salt bridge needs to be dipped into the solution. So this is my salt bridge which is going to be here. Yeah, I think so. I have labeled, if I have forgetting anything, so we can, salt bridge is there, voltmeter, hydrogen gas, platinum electrodes, concentration, and the platinum electrodes. Yeah, we are done. We are having 3 marks for this part. Okay, let's move to the next question, next part actually. Okay, equal volumes of 1 mole per dm cube SN2 plus. Now this question is going to be, which is going to bring your thought process alive. So equal volume of 1 mole per dm cube SN2 plus and 1 mole of dm cube of Cl minus are mixed. Use relevant E naught values to explain whether the reaction occurs between these two ions or not. So now we have to go back to the table which was given to us, and we have to pick Sn2 plus and Cl minus. Okay, so if I scroll back up and let's use a highlighter here. So we have Sn2 plus or Sn4 plus. It was giving us Sn2 plus. So Sn2 plus key, what are the equations? So I have Sn2 plus here and Sn2 plus here, and I have chloride which is here and here, and let's label the equations so we know which equations we are talking about. 1 2 3 4 5 6 7 8 and 9. Okay, so we are talking about the reactant being Sn 2Cl minus, Cl minus and Sn2 plus. These are the reactants. Now you know that in order to calculate the E naught cell, one E naught value has to go forward and one has to go backwards, right? So when we look into that, we have to pick and choose, and we have to check what are the possible combinations we can have, and which E naught is going to be giving a feasible reaction. That means your E naught value needs to be positive. If it's coming to be negative, then there's no use, because E naught negative means that it's not going to be feasible reaction, right? Okay, so using that, let's use a red color. Sorry about my throat. Okay, so for this reaction, so let's suppose my I need Cl, and this has 1.36 E naught, and I have Sn2 plus, which is going to be the reactant. So if I choose equation 1, yeah, okay, so I have to pick between, I can have different combination. I can have 1 and 4, I can have 3 and 5 as well. Yes, yeah, and I can have 1 and 4 as well, right? So let's look at what E naught values I am checking, and I'm going to check which E cell is going to be possible. So if I look equation number 1 and equation number 5, you can see that these are going to be my reactants. So one has to go backward. So if this reaction is going backward, okay, so this reaction has to go forward. So Sn2 plus is going to go in this direction, and it's going to accept the electrons, and it is losing the electrons, right? It's losing electrons and it's gaining electron. So you know that this is going to be possible in this case. So I can have equation 1 and 5. So if I check 1 and 5, so this is 1, the E naught which goes right, and the E naught which goes left. So E naught equals to, the one which goes right is minus 0.14, minus we are going to have 1.36, and the E naught value is going to come in the negative. And if I plug this into the calculator, what I get is minus 0.14, but it's going to be negative either way. 1.36, it gives me 1.5 volts. It gives me minus 1.5 volts. So 1 and 5 can't be feasible, right? 1 and 5 can't be feasible. Why? Because it's giving me a negative E naught. Okay, let's check with another one. Let's check which one should we check? We can check 3 and 5. Okay, so we have checked 1 and 5, and we have chlorine in the third equation as well. So let's check 3 and 5. So if I check 3 and 5 now, so 3 is basically going where? Third equation is going to go backward in order the 5 equation to go forward. So if I look at this third, this is going to be what? Minus 0.14, the one which goes right, minus the ones which goes left, plus 0.89. Again, E naught is going to be negative again, right? So if I plug this, I'm getting 0.14, sorry, minus 0.14 minus 0.89. It gives me 1.03 with a negative sign, which is again not a feasible reaction. E naught or E cell needs to be positive. Okay, now what else combination do I have left here? I can also check 3 with 5. Have we checked 3 with 5? No, we have not. We have checked 3 with 5. We have checked 5 and 1 as well. That means both are going to give negative as well, right? Yes. Let's look at the question again. What was the question asking us? Okay, so equal volumes of 1 mole per dm cube and 1 mole of chloride are mixed. Use relevant E naught values to explain whether reactions occur between these two ions. So you can see that E naught values for both the cases are coming to be negative. So you have to actually write that down. You have to show your working. That's it. So you will say that, okay, E cell for reaction 1 that was one was minus 0.14 minus 0.89. I've done the calculation above. And E cell for reaction 2 was minus 0.14 minus 1.36. And both these values were giving a negative E cell. So no reaction is going to happen. Use a darker color, I think. Yeah, let's pick a darker green. Okay, so equal volumes of 1 mole per dm cube SN2 plus and we have VO2 plus are mixed. Write an equation for the reaction that take place in the resulting mixture. So we have SN2 plus and VO2 plus. Let's go back up to the table. And VO2 plus and SN2 plus. So they means using a different colored highlighter probably now. Let's use a yellow. So we have the reaction which is going to be between 8 and no, between, we can have, now two equations have VO2 plus, right? So we have VO2 plus in two equations. This is VO2 plus and this is VO2 plus, which the question is requiring. And it is asking us for SN2 plus and this is SN2 plus two equations. Okay, let's go back to the question. Equal volume SN2 plus and VO2 plus are mixed, right, equation. Okay, so firstly, we have to do what? We have to pick an equations again, like we did earlier on as well. And I will be using some part of my screen here to do this solving. And let's do dark color. Yeah, okay, darker green would do. Yeah. Okay, so we have this reaction. So in this reaction, we know that one reaction goes forward and the other reaction goes backward, and it's a redox reaction. So if I check for equation number 4 and equation number 8, so I have to choose between 4 and 8, and I can check if it is going to happen or not. And I can also check between, because we need SN2 plus in my reactants. Okay, so SN2 plus needs to be in my reactants, and we have equation 8. So equation 8 is basically gaining electrons if you look at it. So this is gaining electrons and this one here is losing electron. That means if it's gaining electron, the equilibrium is going to be in the forward direction and equation 9 is going to be in the backward direction because of that reason. So if I check 4 with 8 and 9 both, so 4, if I'm using the gaining electron, this needs to lose electron. So if it is losing electron 2 plus to 4 plus, yes, it's going to move in this direction. This needs to go backward and it's need to lose electron. So if I check 4 and 8, that could make sense. That means SN2 plus is going to form SN4 plus plus 2E minus, which is happening. And number 8 equation is my VO2 plus. VO2 plus plus 2H plus plus E minus is going to go forward. It's going to form V3 plus plus H2O in this case. And the one which goes forward, if I have to calculate the E cell for this, E cell is going to, the one which goes forward, that is 8.34 minus the one which goes backward. In this case, it's going to be 0.15 and it is going to give me a positive E cell. Congratulations on that. And whatever the E cell, they've not asked me to calculate that for now. Okay. So this is going to happen because of this reason, yeah. Yes, so this is going to, and let's check 4 and 9 as well, or 5 and, yes, we can check 5 as well. We can check 5 and 9 as well, or 4 and 9 as well for that reason. But this is going to give me 0.34 minus 0.15. It's going to give me 0.19, which is a positive value. So yes, it's going to be feasible. All right. And if I check, okay, so if I check 4 and 9, that's not going to make sense, right? Because both of them are losing electron. So we need to have one equation losing electron and one gaining electron. So I don't have to check between 4 and 9 because I'm happy with 4 and 8 right now, right? I can check between 5 and 9, sure. So sorry, थोड़ी सी खिचड़ी पक गई यहाँ पे because of too many colors. So if I have to check between equation number 5 and equation number 9, so this is my equation number 5, which is Sn2 plus. Okay, so this is basically gaining electrons and this is losing electrons. So gaining and this one is losing, yes. And if you look at these two equations, and if I check between 0.14 and 1, this is going to give me, so if I have to check between 5 and 9, so that's going to be the one which goes forward, that is minus 0.14 minus 1.00. So this guy is going to give me a negative value, so not feasible as well. So I'm happy with 4 and 8. And then I think they have asked me to write a balanced equation, right? So I'm going to use these equations and I need to balance the electrons as well. Yes, let me go to the question now. Okay, so we have picked up what equations are we using as well, right? And now let's write the equation. So we had space constraint for sure, so I'm writing it here. So we have Sn2 plus is going to give us Sn4 plus 2E minus, and the second equation was VO2 plus 2H plus E minus, I think. E minus is going to give us V3 plus H2O plus, yeah, sorry about that, I keep on writing excess of everything. All right, so let's balance these two equations, and in order to balance these equations I will have to make the electrons balance. That means this equation needs to be multiplied with a 2 here. So if this equation needs to be multiplied with the 2, this is going to become 2 here, 4 here, 2 here, 2 here, and 2 here. I've just balanced it. The electrons get cancelled and the net equation becomes what? Let's write for the net equation now, which comes out to be Sn2 plus 2VO2 plus 4H plus gives 2V3 plus 2H2O. Right, 1 mark for picking the correct equation and 1 mark for writing the correct equation. Okay, the next part is for electrolysis, which we are still working to get a hang of. Okay, so we have a solution of SnCl2 which is electrolyzed at for a measured time using a steady current. A mass of 2.95 grams of tin metal is produced at the cathode. Aluminium is electrolyzed at the same time, and this reaction is happening as well. Okay, so firstly we know that Sn2 plus plus 2E minus is going to give us Sn in this case. So the mole ratio for electron to for Sn2 plus to that is going to be 2:1. Okay, we need to know this as well. Okay, so we have 2.95 grams. So we are going to start off with moles of Sn, and 2.95, the AR of tin is 116.7, so 2.95 over 116.7, which gives me 0.025 moles of tin. Now I have to find the number of moles of electrons, and we have 2:1. That means number of moles of tin is going to be multiplied with 2 moles of Sn multiplied with a 2 to give us the number of electrons here, because I've written the mole ratio above, and this is going to give me 0.0505 moles of electrons. Okay. Now to calculate the mass of aluminum metal produced at the cathode, give you answer to 3, and for the same time by the same current. That means the number of electrons are not changing. But when I talk about aluminum, I get 3 plus 3e minus in equilibrium, forming Al, and the mole ratio for aluminum to aluminum ions to electrons is going to be 1:3. So number of electrons which we just calculated, because the current is same, that's going to be this, and I have to find the moles of aluminum, which comes out to be 0.0505 divided by 3, and it gives me 0.0168. And I have to find what? I have to find the mass. So you know that mass equals to moles multiplied by the AR, and that is 27, and the moles are 0.0168, and when I solve for it, I get 0.455 grams as the answer. Okay, chale, we will be talking about more of these questions in my later videos, inshallah. Okay, take care.